let us start. So today we'll discuss design of clutches, right? So actually, as you know, the clutch is an element, right, which is allow operator to connect or disconnect the source of the power transmission system, right, at the wheel, right. So this is how we will first define the clutch, right? So as we have already defined, right, clutch is an element, right, which is to connect or disconnect the source of the power
Sir, your voice is low, sir.
okay. So now am I audible clearly or
Yes, sir.
okay. So the source of the power transmission system at the wheel of operator, right? So it is generally used to connect the driving shaft to the gearbox, right? So it is allowing operator to connect or disconnect the source of power transmission system, right? So generally coupling clutches and brakes, couplings, clutches and brakes, right, are almost similar. In case of coupling, there is a rigid bond between the components, right? Like shafts are joined with couplings. So once they are joined with the help of couplings, it cannot be detached, right? But in case of these clutches and brakes, the two elements are engaged and disengaged at the will of operator, right? So as we already discussed brake, if we talk about brake, the general construction is you are having a rotating drum, right? And in case of that shoe brake, you are having that shoe or block, right? So what happens in case of uh, this brake is, in case of this brake, initially uh, this drum is having motion, right? Rotatory motion, right? While this shoe is stationary, right? Now, and in case of or after application of brake, if you discuss about the final state, then in that case, drum and this shoe, right? This both are standstill after the application of brake, right? Similarly, if you discuss about the clutch, then in case of clutch also, if you discuss about the initial and final condition, then what happens in case of clutch is initially uh, you are having one driving member, right, and one driven member. So driving member will have this rotatory motion while driven member will be stationary. But after the engagement of this clutch or after the application of this clutch, what is going to happen is both driving and driven member will have motion. That is, both will have motion. So this is how we are having this basic things regarding this coupling clutches and brakes. Now there are various types of uh, clutches, right? So if you go for
Excuse me, sir.
yes,
In case of clutch, initially it is in engaged position.
uh, yes, right. Initially it will be engaged, right?
So driving and driven both will be rotating initially.
No, 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 no. Once See, there is a, what we can say that this driving shaft is going to be connected to your driven shaft once you apply that, what you can say, that once you apply the gear, right? If you talk about the your automobile, then there is a neutral gear. So in neutral gear, actually, there is no transmission of torque or anything. Once you shift the gear, once you go to the first gear, then there will be transmission of torque will start from driving shaft to the driven shaft, and in that case, there will be driving shaft in motion, and the driven shaft will be at a certain stationary condition or other condition, right? So that your driving shaft will take your driven shaft to the same speed at which it is rotating, right? Okay.
So engaged position we are taking as final.
Yeah, see, whenever you are applying that clutch, means whenever you are pressing that clutch pedal, at that time disengagement takes place. Right, then only it will allow you to shift the gears in your gearbox.
Yes,
Are you getting what I'm saying?
yes, sir.
Right. So here, as you are seeing, we will discuss this square jaw clutch and single plate clutch, right? So if you see, we will be more focusing on this single plate clutch, right? So as you can see in this single plate clutch, it is in this engaged condition. So during this, the power will be transmitted from this driving to driven shaft. But when you are shifting the gears, this will be disengaged, right? Then only you will be able to shift the gears, right? Okay,
Yes, sir.
okay. So now in case of this types of clutches, you are having this positive contact clutch, right? And this friction clutches, then this electromagnetic clutch, and this fluid clutches and links. So we will be actually more focusing on this friction clutches, right? And in case of this positive control clutch, there is this square jaw clutch, spiral jaw clutch, right? And the centrifugal clutch. All these are, toothed wheel clutch would be yours. Centrifugal will be this frictional clutches. So in this frictional clutches, you will have this single and multi-plate clutch. Then this cone clutch and centrifugal clutch. Right. So in this given figure, you are having this square jaw clutch, which is positive displacement tap, and this single plate clutch, which is based on this frictional clutches, right? It will be having frictional lining as it is mentioned. Right? Generally, asbestos is used as frictional material, right? So here, in case of this square jaw clutch, this square jaw clutch is having this positive displacement clutch. So as you can see, here you are having this kind of arrangement of this jaw and socket. So when it will get engaged, it will work without any slip. But the limitation of this kind of clutch is it can be having engagement or disengagement when both the shafts are at rest or both are running almost at the same speed. Then only this will be working, right? This kind of positive displacement clutches. Well, in case of this frictional clutches, any speed of driving and driven shafts are allowed. Right? So this is how most of the times these frictional clutches are being used, right? So now if we go for this torque transmitting capacity of this frictional clutches, then as you can see, In this figure, it is mentioned that what are the different parameters, like this d is outer diameter of friction disk, and that small d is inner diameter of friction disk. P is the intensity of pressure at radius r, and capital P is force, right? And this MT is torque transmitted by the clutch. Here, this frictional force is shown on that particular element, which is defined in this figure. Right. So, if first you will consider this elemental area at radius r and of thickness dr in the radial direction, then that elemental area will be this 2 pi r dr, right? And the axial force will be given by pressure into this area, right? This 2 pi r dr. So once you have this force, then you can calculate frictional force and frictional torque, right? So from this you can have frictional force. See, these are all acting on that element only, right? So this frictional force will be this mu p into this 2 pi r dr, and this frictional torque will be again we are going to multiply with this radius, right? So this is how you will have the frictional force and torque. Now here we have considered only that simple element. So basically, as you are seeing, looking in this figure, this disc is having frictional lining in this particular area, right? Which is mentioned with this small d to capital D. Right? If you consider this as inner diameter and this as outer diameter, right? Then this frictional lining is provided in this area as mentioned here. So what we have done is we have considered all this frictional force and torque for this element only, right, for now. So in order to get total force and total frictional torque, we need to integrate over this area, right? So let us integrate that in order to get the total force P, right? This is total force P, right? So as you can see here, this will be from that small d by 2 to capital D by 2. Basically from inner radius to outer radius, that will be the total area, right? So this is 2 pi dr will be area, right? So, and then into that mu into P. Right, now here in this particular integration, this 2 pi is what we can say constant, right? So here you will have this plus d by 2 plus d by 2. Actually here we are integrating this axial force and this. So in that we are not having this particular friction coefficient, right? So you can remove that. So here we are having this total axial force as this 2 pi in integration that small d by 2 capital D by 2 dr dr. It will be the total force. Now if you go for that frictional torque,
Excuse me, sir.
sorry, huh?
How how, how it minus d by 2?
It is not minus d by 2, it is d by 2 to d by 2 only, right? It is not minus d by 2. Okay,
Okay.
yeah. So this MT is this frictional torque. Now we are going to integrate. Right? So if you integrate it from d by 2, then it is CP 2 pi r dr. into R. So here also if you take out the constants, the 2 pi mu, and it will be given by this expression, right? So this is the total frictional torque and total axial force, right? This equation will be right. So we will use this equation, right, now for further calculation of this axial force and this frictional torque in different condition, right? Because uh, you will be able to calculate this by considering two different theory, as it is mentioned here: uniform pressure theory and uniform wear theory. Right. So now, what is this? We will go one by one. Right. So if we first go for this uniform pressure theory, then as you can see in this figure, the pressure distribution is assumed to be same across the area as it is mentioned. So generally, for new clutch, this theory applies, right? So when the clutch is almost new and it has just started its function, then almost this force applied or pressure applied will be same throughout the area, right? While after some particular duration or after some life of this clutch, it is going to be worn out, right? So at that time, that uniform wear theory is going to be applied. So which is mentioned in this particular figure. We will discuss that uniform wear theory also, right? So here first let us discuss this uniform pressure theory. It is generally applied for this new clutch. So now if we apply this in calculating this total axial force and total frictional torque, right? So this equation 1 we have written is like this, right? 2 pi that P R dr. Now what we are considering in uniform pressure theory is this pressure is constant. So you can simply take out that pressure so that your uh, this R dr will be integrated from this small d by 2 to capital D by 2. So here you will get this 2 pi P R square by 2, right? D by 2, 2 by 2. So it will give you this 2 you can take out, right? You can P by 2 and R square will be the D square minus D square by 4, right? So basically you will get the pi P, right, into D square minus D square by 4. This is your total force in case of uniform pressure theory. Similarly, you can also calculate the frictional torque in case of this uniform pressure theory. That is, this we have written, right? This 2 pi mu d by 2 d by 2 pr square dr. Here you will take out that pressure also because we are considering it as constant. Right, so here this 2 pi mu p, I am directly putting this d cube minus d cube, right, by 8, right, and this will be actually this d by 2 and this d by 2 will be this d cube minus d cube by 8. But in that integration it will be r cube by 3, so that 3 I am putting here, right? So if you do further what you can say simplification, then it will be this pi mu p upon 12, this d cube minus d cube. Now if you divide this equation, let us write this equation as equation A. this is B. So if you divide this MT by P, right, then you will have this pi P dq minus dq into this 4 divided by pi p d square minus d square, right? So this will give you this mu by 3 dq minus dq over d square minus d square, right? So this particular MT can be now represented in terms of this axial force as this, right? UP by 3 d cube minus d cube over d square minus d square. Right, so this is how you are having this frictional torque and axial force in case of uniform pressure theory. This P is axial force, right? Don't confuse with that pressure. Now, once you have idea about this uniform pressure theory, you can also go for uniform wear theory. So when this clutch worn out, what happens is this product of P into R will remain constant. So basically what it says is this P is proportional to 1 upon R. It means that in case of this disc clutch, that maximum pressure will be at minimum radius, right? So at this minimum radius, there will be maximum pressure, and that this maximum radius pressure will be minimum. Like that, you are having this particular distribution of pressure. So once you consider this PR is constant, then this wear is actually proportional to the frictional burden. This wear is proportional to frictional work. So frictional work is basically nothing but this frictional force into rubbing velocity. So this frictional force into rubbing velocity. Right? This is frictional force. And this is rubbing velocity. Now, from this, if you consider this n is also constant and this mu is also constant. So basically, this will give you that wear is proportional to this product P into R, right? Now, once you have this idea, then what you can do is you can derive the axial force and frictional torque for this uniform wear theory, right? But what we are doing is, as we know this P into R is constant, we are assuming that maximum force, let us say PA, is at this d by 2, which is the least radius. So basically, this PR product can be replaced with this PA into d by 2. So this will do while deriving axial force and frictional torque in this single plate clutch. Right, so let us say this P is again, as we know, is 2 pi.
Sir,
Yes.
please will you repeat above statement?
Yeah. So this one, right? As PR is constant, what we are doing is we are considering that maximum pressure PA is acting at the least radius d by 2. So in our integration, this PR we are going to replace with this PA into d by 2. Are you getting?
So PA is maximum.
Yeah.
Okay, sir.
So here what we are going to do is we are going to replace this PR with PA into d by 2, because now this PA and d by 2 both are constant. So I am taking it out from the integration. So here your integration will be simple, right? This pi PA d into this d by 2 minus d by 2 equals d minus d by 2. Correct? Is it okay? Hello. Did you get this one?
Yes, sir.
Okay. Now, as you have derived this axial force, let us go for this frictional torque. So here also you will have this 2 pi mu, and here it will be this d by 2 divided to the r square dr. Right? So here what you will have is this 2 pi mu Ea into d by 2 will be for this p into r. Still you will have this r dr, right? So here you will go for this integration r square by 2. So basically this is d square minus d square by 4 into that r square by 2 I have put in here, right? So this will give you pi mu Ea d by 8, right, into d square minus d square. So this is how you are having your frictional torque. Now again, if you consider this as C and this as D, and if you divide this D with C, as we have done earlier, this d by P, then it will give you this mu plus D by 4, right? So I'm not deriving it, but you will find this if you divide this equation D by equation C. So this frictional force in terms of frictional torque in terms of this axial force will be given by this, right? So now if we go and simplify this frictional torque, right, in both the cases, then let us define it as simple expression that frictional torque is mu into P into R, right? RF is this effective radius. So in both the cases, RF is different, right? Uniform pressure theory, uniform wear theory. This is uniform wear theory. Right? It will be D plus D by 4. While in case of uniform pressure theory, it will be given by this expression. So clear this one? Yes or no? Hello.
Yes, sir.
So now you can calculate this example. A plate clutch consists of one pair of contacting surfaces. The inner and outer diameters of the friction disc are 100 and 200 mm respectively. The coefficient of friction is 0.2 and the permissible intensity of pressure is 1 Newton per mm square. Assuming uniform wear theory, calculate the power transmitting capacity of the clutch at 750 rpm. So can you calculate this one? And in this next example, it is uniform pressure theory. So I guess both are same only. So can you try this example? Hello.
Yes, sir.
So please calculate and let me know what are you getting as your answers. Just you can note down the given data, right? That capital D is given as 200 mm, small d is given as 100 mm. The coefficient of friction is 0.2. Permissible intensity of pressure means that whatever we are considering maximum pressure P gauge 1 Newton per mm square, and this angle is 70 rpm. So now can you try this? For first you need to consider uniform wear theory. So can anyone tell which equation you are going to use to calculate this force? Hello. We have derived all these equations, right? Just now.
Yes, sir.
So which equation you are going to use here?
Pi into Pa into D,
Hmm.
capital D minus small d by 2.
Yeah, correct. So this will give you this force. So you have all the data with you, right? You have this pi ratio is given as 1, small d is 100, capital D is 200, right? So this will give you this action force, right? So what will be your answer here?
18.5 kilowatt.
No. Can anyone else answer this question? Hello.
Our 1.67 kilowatt.
1.67. Actually, no, it is
61.
straightforward. Now, this pi is in terms of 3.14 something divided by 2. 8 to 10
15.7.
raised to 4, right? This 100 and this also 100. Right? So it is straightforward. Right?
15.7.
Yeah, it will be around this 1 pi or not 7.96 Newton. Is it correct?
Yes,
Yes,
sir.
Right. So once you get this force, then you can go for that torque. We have written the torque in terms of this force, right? If you remember this pi p by 4d plus t, correct? For uniform VR.
Yes, sir.
So this point 2 into this 1 by 7 or 7.96 by 4 into 200 plus 100. So this will give you answer. Can anyone? This is 4. Right? Yes. Can anyone answer this?
Two 35.619.
Sorry?
235.619.
235. So you have converted it to Newton meter, huh?
Yes, sir. Newton meter.
Yeah, it will be Newton meter. Now you need to calculate the power transmitting capacity. So how will you calculate that?
Equal to 2 pi NT by 60.
Yeah. So 2 pi nt by 60. This torque is this only, right? Mt. Correct? Right?
18.505.
18.505, right? So this is how you have kilowatt, right?
Yes, sir. Kilowatt.
Okay. So once you have this, now you can go for uniform wear theory. Sorry, uniform pressure theory. This is for uniform wear theory, right? As you can see here. Now for uniform pressure theory. For uniform pressure theory, you will have your force as pi 2 by 4 E square minus E square. Right? That EA. So it is EA is 1, right? So this way. So what is this capital P? Anyone? Is it this much? Anyone got this?
23561.94.
Correct, correct. So now for this uniform pressure theory, this frictional torque with the help of this axial force can be calculated from this relation. Right? So here also you have everything with you. Mu is 0.2, P you have calculated, you have inner and outer diameter. So can you tell me what is this frictional torque? Anyone? Can anyone tell me?
366.5.
Sorry?
366.
Yeah, 366.519. Right?
5 Newton meter.
Now you need to again calculate the power. Right? 2 pi n by 16, 20. Then RPM is given as 750, right? So here power transmitted is
28
28.79
kilowatt.
So generally the design is based on the uniform wear theory, right? Because it gives some this conservative power which is transmitted. Because as we know in practice, uniform pressure theory cannot be applied throughout the operational life of clutch. It is going to get worn out, right? So generally this uniform pressure theory is applied, right? So which gives this what is a conservative value of power transmitted. Now once you have idea about this, then you can calculate this also, right? So let us see here an automotive plate clutch consists of two pairs of contacting surfaces with an asbestos friction line. The torque transmitting capacity of the clutch is 550 Nm. The coefficient of friction is 0.25. Permissible intensity of pressure is 0.5 Newton per mm square. Due to space limitations, the outer diameter of the friction disc is fixed as 250 mm. Using uniform wear theory, calculate the inner diameter of the friction disc and spring force required to keep the clutch in an engaged position. So can we try this? Hello.
Yes, sir.
So here the data are given here.
Sir, how to calculate
Kindly
string?
mute yourself. First, you can note down the given data right here. If you note down the given data, the dot transmitted is 550 Newton meter. Then this capital D is 250 mm. Mu is 0.25. PE is 0.5 meter square. Number of pair of surface protecting surface is equal to 2. So actually whatever equations we have derived is for only one pair of contact, right? So here we will consider the torque as mt by 2 instead of this 550. This we will consider 550 by 2, right? So this 550 by 2 is 275. So for calculating our given or asked data, you will consider torque as 275. Right, and you need to use uniform wear theory in which mt is given by pi mu E d by 2. Sorry, d by 8. Is pi mu E d by 8 into d square minus d square. So in this equation you are having all the data here is 275 into 10 raised to 3 is pi, mu is 0.25, PA is 0.5, we don't have this 2. So now actually when you solve this equation, right, with trial and error, you will find that you will find it is a cubic equation, so you will have 3 different roots, right? So but from that different roots you can consider one of the feasible root, right, which will be t is equal to 174 mm. Okay, so do you want to generate that cubic equation and you need to try to solve it? Hello.
Yes,
Yes.
sir.
So please try and tell me whether you are getting one of the root is near to this one. Capital D you are having as 250 mm. So you will have cubic equation in terms of this small d. Done? Anyone got the answer? It is there, right, directly in your scientific calculator. Or you can even put this 174 once you generate that cubic equation and you can check whether it is satisfying it or not.
Sir, we can't solve cubic equation by gate calculator.
Maybe yes. Then you need to go for this trial and error. Right? Or
If in
Yes,
gate such question come, then how to proceed, sir?
in that case, I guess it will be trial and error, or in that case, they may avoid this kind of what you can say questions or this kind of parameter, so that it will not be that much because otherwise it will be very time consuming, right? So for now, if you have scientific calculator, at least you can try with that,
yes, sir. 174 correct.
right? So with scientific calculator, at least you are getting this answer, correct?
Yes, sir.
Okay, so once you get this particular small d, then you can calculate the axial force in case of this uniform wear theory. So for that, we are having this pi p a d by 2 d minus t. Right? So now you have again all the data with you. PA is zero point 0.5, small d, capital D is already with you. 250 and 174, right? So what will be this axial force which is required to make engage this pair of this? What is this force? Anyone? Is it around this 10,396 Newton almost? Yes or no?
Yes, sir.
Yeah. So here, if we go for the multi-plate clutch, then in this multi-plate clutch, actually you will have pair of disc on driving and driven shaft, right? And here, whatever equations we have derived, we need to multiply that equation of the torque with number of discs, right? So in case of uniform pressure criteria, uniform pressure, your frictional torque can be represented with this mu p z by 3 mu p z by 3 into the dq minus dq by d square minus d square. Similarly, for uniform wear theory, this empty can be given by this mu p z by 4 d minus d. Here z is number of plate. And how will you calculate this number of plate? Or actually, this number of pairs of contacting surfaces, right? Not this number of plate, because number of plate will be different than number of these contacting pairs. We will see how we can calculate that number of contact pairs. So as it is given that number of discs on this driving and driven shaft may be Z1 and Z2 respectively, right? But in case of this number of contacting pair, it is given by this Z1 plus Z2 minus 1, right? Why? Because there will be one less what you can say contacting pair, right, in comparison to total this number of this, right? So as you can see in the given example, you are having 3 discs on this set A, right, and 2 discs on this set B. It means it is driving and driven shafts A and B. So when you make this pair of contact, then it will be one less than the total number of discs, right? So as you can see this, it is self-explanatory, right? So this is how this number of contact in pair will be given with this Z1 plus Z2 minus 1, right? Now from this we can try this example, right? An oil immersed multi-disc clutch with cork sheet as the frictional material is used on a scooter engine. The friction disk of such a clutch is shown in the figure. Now the torque transmitted by the clutch is 10 Newton meter, the coefficient of friction is 0.2, permissible pressure is 0.1 Newton per mm square, inner and outer diameter are 65 and 95 mm. Then there are radial slots on the frictional surface for the circulation of the coolant, which reduces the effective friction area. Now to account for these slots, the number of contacting surfaces can be increased by 5%. Assuming uniform wear theory, calculate the required number of contacting surfaces. Right. So now here also you can first note down the given data, right? So what is given is MT is given as 10 Newton meter. Then this capital D as 85 mm, this small d as 65 mm, this mu is 0.2, and this PA as 0.1 Newton per mm square. Right, so once you have this given data, right, then this operating force you can calculate, right? Operating force is, in case of this uniform wear theory, is mu PA d by 2 is d minus d. So from all this given data, what will be this force? Can anyone tell? Hello. Can anyone tell? the answer?
28.5.
Sorry?
28.5 Newton.
Mm, This will be pi into 0.1. That is
1.95.
65 by 2 into 95 minus 65. So now, can you tell me now?
1.95.
How come it will be 1.95? Here it is 30 by 2, that is 15. So 65 into 15 into 0.1 into pi. How can it be 1.5?
Is it pi or mu?
Oh, sorry. It's pi. Yeah, sorry. Now you can tell me. Yeah, what is the answer? Anyone?
306.305.
Yeah, it is almost around this 306.3 Newton. Now, once you know this force, then you can apply this torque equation, which we have just now noted for a number of this Z. It is given by this mu p. Z and 4t plus t. Correct? This is what we have just now noted for multiply plus. Yes or no? Hello.
Yes, sir.
So from this you can calculate the number of discs because you have empty with you, right? You have p calculated, then mu is already there, and this d and capital D and small d also with you. So tell me what is the z? Let us convert it into Newton mm.
Sir, is it 4?
Yeah, it is 4.08. So you have to also consider the effect of this radial slot as it is mentioned. Right, so Z will be almost coming down 4.08. So here as it is mentioned here that contacting surface, as you can see here, this to account for this radial slot, the number of contacting surfaces can be increased by 5%. So considering that radial slot, is that final will be 1.05 times the Z we have calculated. So that will come around 4.2 B, right? So you can go with number of surfaces as 5. Is it okay?
Sir, we should go for higher value.
Yes, because you need to transmit that much amount of torque. Right? If you go for less amount, then that much amount of torque will not be transmitted. Are you getting?
Yes.
So now, once you have this idea, then let us do of similar kind. A multi-disc clutch consists of 5 steel plates and 4 bronze plates. The inner and outer diameter of the friction disc are 75 and 150 mm respectively. Coefficient of friction is 0.1 and the intensity of pressure on friction lining is 0.3 Newton per mm square. Assuming uniform wear, calculate the required force to engage the clutch and power transmitting capacity at 750 rpm. So now I guess I will not tell you anything. Can you calculate it by your own?
We'll try, sir.
Yeah, please tell me what are the answers, right? Final answers. I'm giving you 2 minutes of time. I will tell you everything.
Sir, is the force 2.65 kilonewton?
Yeah, correct. Force will come around 2.65 kg. Correct. Did you get the power transmitting capacity?
The number of contact surfaces is
Yes, correct. So then what will be your answer for the power transmitting capacity?
Is it 9.4 kilowatt?
Correct, correct. So here, if I first write the given data, then it is 150 mm, right? Then this T is 75 mm. Nu is given as 0.1. This N is given as 750 rpm. PA is given as 0.300 square. The number of steel plate Z1 is 5, the bronze plate Z2 are 4. Right, so contacting surface is Z is Z1 plus Z2 minus 1, that will be 8. Now if you first calculate the axial force, then it is that pi PA d by 2 is T minus T. Right? So this will give you almost 2.65 kilometer. Right? This is correctly pointed out. Then you can calculate this frictional torque from this force, axial force, right? UT pi is equal to T plus T. So it will come around 119.22. Correct? Newton meter. Yes or no?
Yes, sir.
Then it will be 2 pi n by 16 into nt. Right, this power, which is almost 9.4 kilowatt. Right? So now once you have all this idea with you, you can try this, which is from gate 2006, right? A disc clutch is required to transmit 5 kilowatt at 2000 rpm. The disc has a friction lining with a coefficient of friction 0.25 over radius of the friction lining is equal to 25 mm. Assume uniform contact pressure of 1 megapascal. The value of outside radius of the friction lining is. So I guess you can try this one. First you need to calculate the friction torque, right? Because power is provided. So 2 pi into 16. Power is 5 kilowatt. So 2 pi and is 2000 into this torque, right? Which is nothing but the braking torque empty. So what will be the answer for this torque? Can anyone?
Torque is 23.87 Newton.
Correct. It will be 22.8 centimeter. Right, it is nothing but that empty direct. So now once you have empty with you, you can write this empty in terms of that axial force, right? So what is that equation in case of this uniform? Which theorem last? Uniform contact, right? Uniform contact pressure. So what will be empty in case of uniform contact pressure? Is it pi mu p by 12 d cube minus d cube? Yes or no?
Yes,
Pi
sir.
mu p
By 12, d cube minus d
d
cube.
cube minus d cube. Here this P is this uniform pressure, 1 megapascal.
So is the answer A?
Yes, correct. Answer is A, 13.4. So if you put all the given data, it's 23.87 Newton meter to Newton mm. One second. Yes, correct answer is A. So if you put all the given data, this pi mu is 0.25, right? This P is 1 megapascal, so this is Newton per meter square on right? So D is as capital D and small d. So you need to calculate outside radius. So d cube is known, right? So small d will be 50, right? Because radius is provided, correct? Radius is provided as 25, right? So I have multiplied it with 2. Is it okay?
Yes, sir.
So now this D will be this 78.8, right?
Yes, sir.
So R will be getting as 39.4, correct?
Yes, sir.
Okay, so let us go to the next one.
Sir, how 12 came there?
Actually, it is this in terms of this pressure, right? It is not in terms of that axial force. When you write it in terms of axial force, at that time it will be that mu into capital P by 3, then d cube minus d cube means capital D cube minus small d cube upon capital D square minus small d square. Okay?
Yes, sir.
Yes.
Okay. So here now a clutch has outer linear diameters 100 mm and 40 mm, assuming uniform pressure of 2 megapascal, coefficient of friction linear material is 0.4, torque transmitting velocity. It is a straightforward problem, right? Hello.
Yes, sir.
So can you tell me the answer? This empty this whatever we have just now written, this mu p to pi dq minus dq. The same will be there, right? It's 0.4 is 2 Pascal. Is it correct? Hello.
B, sir.
Yes, it will be almost this 6 Newton meter. Okay. So the next is a disc clutch with a single friction surface, has coefficient of friction equal to 0.3. The maximum pressure which can be imposed on the friction material is 1.5 megapascal. Outer diameter of the clutch plate is 200 mm and its internal diameter is 100 mm. Assuming uniform wear theory for the clutch plate, the maximum torque that can be transmitted is, so you can calculate this also, right? Yeah, the given data is mu is given as 3 maximum pressure is given as 1.5 Pascal. Outer diameter is 200 mm. Inner diameter is 100 mm. So now you can calculate.
530.14.
Correct. Torque transmitted. Almost around that 530. So which equation we are going to use here?
Pi by 8. T into D.
Sorry.
1 by 8 pi into.
So this pi mu p a d by 8, right?
Yes, sir.
D square minus d square, right?
Yes, sir.
So in this all the data is given, right? So it will give you answer around 530 Newton meter. Correct? Right? All of you are getting this?
Yes, sir.
Okay. So then next. A single plate clutch has a friction disc with inner and outer radii of 20 mm and 40 mm respectively. The friction lining in the disc is made in such a way that the coefficient of friction mu varies radially as mu is equal to 0.01 R, where R is in mm. The clutch needs to transmit a friction torque of 18.85 kilonewton mm as per the uniform pressure theory. Now, the pressure in Pascal on the disc is. So here you need to think, right? Because here your mu is varying with respect to R. So what we have written for that uniform pressure theory in case of this frictional torque, anyone remembers? Actually what this 2 pi r dr was the area, right? And that
Into mu.
P is the pressure, so this is the force. So we have multiplied it with coefficient of friction, so that frictional force, and then again we have multiplied it with R to get the torque. Right? This is what we have done. Correct? Right?
Yes,
For
sir.
that elemental area. Now we have then integrated it from small d by to capital D by 2. So here pressure is constant at uniform pressure theory. So 2 pi P will be constant, right? And this mu r square dr will be there. Is it correct? Why mu has come inside this integration? Because mu is varying, right? Because mu is given as 0.01 r. Are you getting it? Yes or no?
Yes, sir.
So this is how we will get this 2 power p. We can here write that r I and RO also, right? In place of this small d by 2 and capital D by 2, because here in your problem statement, what is given is radius only, right? Inner and outer radius. Sorry?
0.5
Your answer, what answer you are getting? 0.5 MP, yes, correct, correct. 0.5 MP is correct answer. So this 0.01 I have taken out, then R cube dr So is 2 pi p into 0.01, r is to 4 and 4, and here 2240, right? Ri and ro. So once you simplify this, what is p? So p is,
That is to be found out, sir.
it is to be calculated, sir. So this P you need to calculate. MT is provided, right? 18.85 kilometer. And okay. So here it will be by P 101 and 40 is to 4 is 40 is to 4 by 4. And this MT is 18.85 times to 3. Is it correct? Which will give you this pressure.
Yes.
So this pressure will be 0.5 MPa. And all of you are getting the same?
Yes, sir.
Okay, then let us go to the last question. In a disc type axial clutch, the frictional contact takes place within an annular region with outer linear parameters to 50 mm and 50 mm respectively. An axial force F1 is needed to transmit a torque by a new clutch. However, to transmit the same torque, one needs an axial force F2 when clutch wears out. If contact pressure remains uniform during operation of a new clutch, while the wear is assumed to be uniform for an old clutch, and coefficient of friction does not change, and the ratio of F1 by F2 is. So here, how can you approach?
Force by uniform pressure to uniform wear.
Yeah, first you have to calculate that force for uniform pressure, and then uniform wear, and then you need to take ratio. Correct?
Yes, sir.
So calculate and let me know what are you getting.
Sir, wear is assumed to be uniform means
It means you need to consider that uniform wear.
okay.
Yeah. So we have actually written that equation in terms of that mu WRF, remember? And then RF was for uniform pressure and uniform wear, if you recall it. Are you getting?
Yes, sir.
Right. So this W will also vary along with this RF. So for MT1, if you are considering uniform pressure, then mu W1 RF1, let us say uniform pressure. Then MT2 will be mu W2 RF2, let us say uniform BF, right? So what you need to do is you need to take the ratio of W1 by W2. RF1 and
The answer
RF2
will
you know.
0.872.
Sorry?
The answer will be 0.8572.
It is almost around 0.87. So can you tell me what is W1 RF1 pi upon W2 RF2, right? Then actually this both are equated, right? So let me write it as equal to 1. So basically W1 RF1 is equal to W2 RF2, right? So from that, this W1 and W2 is RF2 by RF1. So what is RF2 for uniform wear? What is the radius?
75, sir.
Where where it is mentioned? Oh, for actually for that RF1, is it this? 250 plus 50 by 4. Are you telling that,
Yes,
right?
sir.
Huh? So RF1 is DI plus, means D plus D by 4. Is it or not?
Yes.
Right. So then what is this RF2?
R2 is 75, sir.
It is this
1
1 by
by
3 d cube
d square
minus
minus
d cube
d square
upon
by
d
d
square
square minus
minus
d.
d square. Correct? Yes?
Yes, sir.
So if you put all the values, capital D and small d is given, right? Here it is in terms of diameters only. So basically this 1 by 3, 250 cube minus 50 cube, 250 square minus 50 square, divided by 250 plus 50 by 4. Correct? Hello.
Yes, sir.
Yes, sir.
So now if you go for finding this W1 by W2, then it is almost around 0.871. So are you getting this? Yes or no?
No, sir. I got
Sorry?
0.857.
Huh?
I got 0.8572.
8572. Huh? So it may be.
Yeah.
Anyone else also getting 8572? Anyone else? Hello? Anyone else? Okay, then we are going with this only. So it is almost.
0.871, sir.
Sorry?
0.871.
0.871, huh?
Yes, sir.
So anyway, it is around 0.86, right? Let us see. Right? Okay. So today we are keeping it up to here. Okay.
Okay, sir.
Thank you.